Today we're going to look at rotations in the coordinate plane, and our learning target is I can rotate an object around the origin, and our essential question is what direction and how far do I rotate an object around the origin? Don't forget to fill in your name, class, and date. Feel free to pause the video at any time to write things down. A rotation is a transformation. Remember, transformation just means change or move that moves every point of a figure around one point. And the point that we rotate around is called the center of rotation. And if we track a vertice, let's say we track our pre-image A to our image A prime, we see that the center of rotation becomes the vertex, and now we have an angle that we can measure. The angles that we're going to be working with today are quarter turns, or 90 degrees. If I do a second quarter turn, or have two quarter turns, it's 90 plus 90 is 180. 3 quarter turns is 180 plus 90 gives me 270. And if I rotate all the way back, 4 quarter turns gives me 360. The direction we moved is called counterclockwise. You can always write it as CCW. And that's in a kind of left arced direction. Example 1, explain if the transformation is a rotation. So are we rotating or turning around a point? And if I track the bites in the apple, I see this object is more flipped across a line. So the first image is no, the object appears to flip across a line. If we track the bites in the apple on the second figure, we see it almost looks like a reflection. However, the bites are not on the right side. They're on opposite sides. So this apple has been rotated, has been turned. So the point of rotation is in between the apples. So we can say, yes, the object appears to turn around a point in between the apples. And our last image, we see our apples are both standing up, but just shifted down and to the right. So not a rotation, no, the object appears to slide down and to the right. Okay, let's describe this rotation in words. So remember, we first need to find our pre-image. So find the triangle that has just letters. That's your pre-image. That's where you start. And pick any vertex to track. So maybe I pick S, and I want to track that to S prime. So our job is to describe the rotation in words. So we're looking at turning around the origin and in quarter turns. So here we're doing 1 quarter turn, 2 quarter turns, 3 quarter turns. So 3 times 90 gives me 270 degrees. So we have a 270 degrees counterclockwise rotation. Notice that the rotation is described in degrees and in direction. So we need to know which way to turn and how far. In the second example, we have our pre-image is on top. So let's track E to E prime, moving in a counterclockwise direction. Looks like we just did 1 quarter turn. So 1 times 90 gives us 90 degrees, counterclockwise. Okay. Let's describe these last two. Looking for my pre-image. I see my pre-image is up here, upper right. If I track L to L prime, remember I'm rotating counterclockwise, 1/4 turn, 2/4 turns, so 2 times 90 is 180 degrees counterclockwise. Our last example, this is tricky when the images are on top of each other. I like to track points that are easy to track. They're away from the other points. So if I track C to C prime, remember to count in a counterclockwise direction. So we have 1/4 turn, 2/4 turns, 3/4 turns. 3 times 90 gives us 270. Great, let's graph. Now these are tricky. These are tricky when we're just counting. There is a rule that we'll explore in class, which you might like better. But let's count to start. So we're going to rotate or turn around a point. We're going to turn about the origin. And how far? We're going to turn 90 degrees counterclockwise. So we're looking at 90 degrees counterclockwise. So this method is based on counting. So if we count from the x negative axis, and I want to turn 1/4 turn, excuse me, we would then be reporting on the y negative axis because that's 1/4 turn. Let me show you what I mean. So if I count point I from the origin, I'm going left, I'm on the blue line, 1, 2, 3, 4, and I make a point. But I'm going to report now on the pink line. So I'm just going to count 1, 2, 3, 4, and make a point. I'm going to call that point I prime. Well, maybe I'll make it on this side. All right, next I have K, and K isn't on the blue line. I'm going kind of up from the blue line. So if I rotate that 90 degrees, going up from the pink line, and that's K prime. The last point is J, so counting on the blue line as best we can, 1, 2, 3, and then going up 1, 2, 3, 4. Let's try and repeat that on the pink line, 1, 2, 3, and then up if we were rotated, 1, 2, 3, 4, J prime. Connecting the dots, we want to look and see if we have the same triangle, which we do. We have a rigid motion that's just turned around the origin. We need lots of practice. Let's try again. All right, we're going to rotate or turn around the origin 270 degrees counterclockwise. So that's 3/4 turns. Okay. So if we try counting from our x positive axis and we do 3/4 turns, 1, 2, 3, we're then going to be reporting on our pink line, which is y negative. So we're going to count on our x positive blue line and report on our y negative line. Okay, but this is tricky, so just do the best you can. So from the origin, we're counting 1, 2, 3, and 1 down from G. So if I am now kind of rotating or turning on the origin, I'm counting 1, 2, 3, and 1 down from the pink line. Let's try and plot point F, 1, 2 on the blue line, and then 1, 2, 3 up. So 1, 2 on the pink line, 1, 2, 3. I'll make a point. F prime. E is left, so counting on the blue line, 1, 2, 3, 4, 5. 1, 2, 3 up. So counting on the pink line now. 1, 2, 3, 4, 5. 1, 2, 3. E prime. Connect my dots. Take a look to see if it is the same triangle. Rotated 1, 2, 3 quarter turns. Let's do a couple more. Let's rotate 180 degrees about the origin. So we're looking to move 1, 2. Okay. So let's say I'll count on the y negative axis, and I'm going to do 90 degrees, 180. So I'm going to then report on the y positive axis. Okay, so if I count, if I start with F, point F, counting down 1, 2, 3, and 1 to the left. So I'm going to do the opposite. It's like you're counting slope points. So counting up 1, 2, 3, and to the right. That would be F prime. Let's count E next. So from the origin, 1, 2, 3, 4, and 1, 2, 3, 4, 5 to the left. So instead of down, I'm going to count up 4, 1, 2, 3, 4, and instead of left, I'm going to count 5 to the right. 1, 2, 3, 4, 5. Make a big point, and that's E prime. And G, so 1, 2, 3, 4, 5, 1, 2, 3, 2, 3, 4, 5, 1, 2, 3. Make a big point so I know it's not my thinking marks, and make my triangle. It appears to be rigid transformation, moved 180 degrees. One left. So let's rotate 90 degrees clockwise about the origin. So 90 degrees clockwise, just 1 quarter turn. Let's just try. So if I'm going to, let's say I'm going to count from my x positive axis, and then I'll have to report 1 quarter turn on my y positive axis. So let's count to G. So counting 1 right, 1 on the blue line, and 1, 2 down. So I'm going to count 1 on the pink line and 1, 2 down. That's G prime. Let's count to F. So counting 1, 2, 3, 1 down. So I'm going to count 1, 2, 3 on the pink line, 1 down. That's F prime. And on the blue line, I'm counting 1 on the blue line, and then 1, 2, 3, 4, 5 down. 1 on the pink line, 1, 2, 3, 4, 5 down. And that's E prime. All right. These are tricky, so just do your best in counting, and when we come together in class, we'll practice counting some more and see if we can find a pattern with the rules. We'll see you in class.